Welcome to section 7-1. Today we're going to review how to divide polynomials. You should have done this in Algebra 2. You probably haven't done it since Algebra 2, so we are going to review some of the methods for dividing. The one we're going to use today would be using area models. So just to get started, a little warm-up. It says use a generic rectangle to multiply the quantity of 2x plus 3 times the quantity of x squared minus 4x minus 1. So remember, when we're using the generic rectangle method, we are going to set up our generic rectangle, and it's going to have the dimensions that go with these factors, right? So 2x plus 3 is a binomial, right? And since it's a degree of 1, we'd have our degree of 1 here and our degree of 0 right there. And then we've got x squared minus 4x minus 1, right? And then we'll find the area of each of these individual rectangles, right? So this would be 2x to the third. We've got x squared times 3 is going to give us 3x squared. 2x and negative 4x, when we multiply them, give us negative 8x squared. Negative 4x and 3 give us negative 12x. Negative 1 and 2x give us negative 2x, and then we get a negative 3 down below. Okay, so we take it there and we pull it out and combine all of our like terms. And remember, your like terms should line up diagonally like this. So we have our highest degree is going to be our 2x to the third power. And then we're going to have minus 5x squared minus 14x, and then minus 3. So that is our product there. It's written currently as, the area as a sum. Okay, so that's just a quick little review. We're going to be getting into doing some dividing here. Now, there's a couple ways to look at division. One of the easiest ways is when we're asked to simplify something, and you see we have this fraction x squared plus 3x minus 4 divided by the quantity of x minus 1. And if we have the ability to factor something, we usually try to do that first. Like x squared plus 3x minus 4, we know factors into x plus 4 times the quantity of x minus 1. And then since we have an x minus 1 over an x minus 1, right, we can cancel out those two factors, and we're left with our answer being x plus 4. Okay, so it's nice when it's able to factor, but when you're looking at this second problem, we have 2x to the third minus 5x squared minus 14x minus 3, and we're dividing that by 2x plus 3. Sometimes we run into a problem here because, does this factor? And if we can't get it to factor, then that's going to make it hard for us to simplify it down. Now, we already know the answer to this one, right, because this is the problem we just did above, right? So we know that our answer on this one would be x squared minus 4x minus 1, right? That's from previous slide. But we're going to look at another way to divide that you did last year in Algebra 2 using the generic rectangles. But if you're rusty on it or you forgot, this would be a great opportunity to catch up. Okay, so move on to the next slide. Here it says, let's divide the polynomials by reversing the generic rectangle method. Okay, so as we look at this, right, we've got our 2x to the third minus 5x squared minus 14x minus 3, and we're dividing all that by 2x plus 3. Okay, right now we could say, hey, we don't know what that equals, even though we just did that problem, but if you think about here as an equation, we could get rid of that 2x plus 3 on the bottom by multiplying both sides by that 2x plus 3. Right, and that's how we will think of this. We're going to think of this as we've got 2x to the third minus 5x squared minus 14x minus 3 is the product of something that we don't know times the quantity of 2x plus 3. Okay, so we knew that came from a generic rectangle originally, so let's set that generic rectangle back up, right? Since we know, our 2x plus 3 is a binomial, we'll know that the dimensions on the left side were originally 2x plus 3. And then we're going to take the part of it that we had already found, right, which was our 2x to the third minus 5x squared minus 14x minus 3. Remember, this came from inside the boxes. So what we're going to do first is we're going to take this, and it always comes from right up here, right? Because we have our greatest values here and here, or our numbers at the highest degree. So our 2x to the third goes back in to the top. So what we'll ask ourselves then is this question, 2x times what gives us 2x to the third power? Well, we know that this would have to just be an x squared right here, right? So then we'd say, all right, well, x squared times this 3 should give us this information down here, right? So we know this has to be a 3x to the second power, okay? And now when we look up at the top back here, right, we know we have an actual total of negative 5x squared. So when I take that the positive 3x squared that I have here and I add it to this missing part, it should give me the negative 5x squared. So 3 plus what gives me negative 5? Okay, well, that should be a negative 8x squared, right? Because negative 8x squared plus 3x squared gives us a total of negative 5x squared. Okay, and then we can kind of repeat that process here. We'd say, hey, I've got 2x here. What do I have to have here so that when I multiply times 2x, I get negative 8x squared? And if you say negative 4x, you are correct, right? And then we can distribute it through. Negative 4x times 3 is negative 12x. Okay, well, if we have negative 12x here, and we're going to add some sort of x's here, right? How many do we have to add in there to get negative 14x? Well, we'd have to put a negative 2x in there. Okay, and then again, we go back to that next step here where, oh, okay, I've got 2x here. 2x times what gives me negative 2x? Well, that'd have to be a negative 1. And then negative 1 times 3 is negative 3. Okay, so that means then since we have negative 3 here and we have negative 3 already here, then there's nothing left over. And our answer is our x squared minus 4x minus 1. Okay, if you're remembering, great. If you're not, it's okay. We'll go through a couple more examples. At any time, if you're watching this video, if you feel like you want to pause it, go ahead and try to work it out and then fast forward through to check your answer. You're more than welcome to do that. Okay, so this one says divide, express any remainder as a fraction. So this one, we're probably going to have a remainder. That's your big hint right there. And when you see something like this one is a 5th degree. Let's make sure we're thinking about all of the degrees. We have t to the 5th, and we have no t to the 4th. So we're going to put plus 0t to the 4th. And then we have minus 3t to the 3rd. We have no t squareds. We have plus 3t minus 4. Okay, so we're going to be dividing that. That's what's going to be going inside of our rectangle. So if we set up our generic rectangle, again, our dividend is going to go out on the left side. We have a t plus 1. And then the question always is, how many boxes do I need to make here? Or how many columns do I need to have in my generic rectangle? Okay, well, if you think about it, this one is a t to the fifth. This one is a t. If you did a t to the fifth divided by a t, you should get a t to the fourth, right? So you'd have t to the fourth would be that first column, a t to the third would be the second, a t to the second, a t to the first, and then you should have a constant term at the end. And then you may end up with your remainder being right out here. Okay, so let's see how this works. Let's do it again. So we're going to take our t to the fifth, right? That's our highest one. We put it in that top left corner. And that's going to leave us with a t to the fourth up here. T to the fourth times 1 is going to be a t to the fourth. Okay, we're going to say, well, how many t to the fourths do we have? We have 0 t to the fourths, which means we need a negative t to the fourth here to cancel it out. And that would leave us with a negative t to the third up here. Multiply it through to get a negative t to the third down here. How many total t to the thirds do we have? Well, we had negative 3 of them, so we need 2 more. So minus 2t to the third, which is going to give us a negative 2t squared. We'll multiply it through. We've got a negative 2t squared. We have 0t squared, so we know this has to be a positive 2t squared. That's my cat, just ignore him. I try to. So then we're up here, right, since we've got a 2t. See, he distracted me and ruined my concentration. All right. That's why you should put your phones away when you're doing your work, because it's a distraction too. So 2t times 1 is 2t. Now we have a total of 3 t's, so we need another t up here. So we have a positive t, which means that up above we're going to have a positive 1. 1 times 1 is going to give us 1 down here. Now, remember, we have 1 here, but this is a negative 4. So what do we have to add to 1 to get to negative 4? Well, we're going to have to add a negative 5. Okay, so how does that come into play? Well, our answer, remember, is this whole part of it right here. So we're going to take that, we're going to write it out. We're going to say this is going to be t to the fourth minus t to the third minus 2t squared plus 2t plus 1. And then we'll say you can either do minus 5 over our divisor, which would be t plus 1, or you're welcome to write it like this, where you've got everything is the same up until after the 1, right? And you could always say plus and then move that negative to the top and say plus a negative 5 over t plus 1. Either of those answers would be correct. Okay, so you can go ahead and try this one, see how you do. I would pause the video, try it, and then see if you get the correct answer. All right, I'm going to work this one out. So we've got an x to the fourth plus 3x to the third minus 5x plus 7 all over x plus 2. So just remember, this is like saying x to the fourth plus 3x to the third plus 0x squared minus 5x plus 7. Okay, and so when I set up my generic rectangle, okay, what I've got here, an x plus 2, and then if you think about it, right, if I had an x to the fourth divided by an x, that would give me an x to the third. So I know my first column is going to be for x to the third, second one x squared, third one x, and then I have my constants after that. So I actually have too many rows. I'm just going to erase those ones off there. All right, so here we go. Put the first one in where it goes, x to the fourth, which makes this an x to the third. This would be a 2x to the third. And we need a total of 3x to the third, so we're going to need another one. So sorry, I was trying to color coordinate. Let me just do that. So we need another x to the third, which would make this an x squared out here. X squared times 2 is going to give us 2x squared. Now, since we have 0x squareds, we need this to be a negative 2x squared, which is going to make this a negative 2x. Negative 2x times 2 is going to be negative 4x. Right, and since we have negative 5x's here, it means we have another negative x right here, which is going to make this a negative 1. Negative 1 times 2 is negative 2. And since we have a total of 7, right, negative 2 plus what gives us 7? Well, I think we're going to have to end up with a 9 out here. And since now we have that 9, we can take it and we can write out our answer. So our answer will be x to the third plus x squared minus 2x minus 1, and then we're going to add 9 over x plus 2. That is our quotient. Okay, so hopefully you're feeling good about that. We've got one more example to go through. This one looks a little different. It says divide, express any remainder as a fraction. And you'll notice now we have a 4th degree polynomial on the top and a 2nd degree polynomial on the bottom. So when we think about what this really is stating, right, if we look at all of our missing degrees, we have m to the 4th plus 3m to the 3rd minus 9m squared plus 0m plus 7. And then on the bottom, this is like saying m squared plus a 0m plus 1. So we need to think about those missing terms when we are building our generic rectangle. So as I do this here, right, I'm going to have 3 rows, because I need one for m squared, I need one for 0m, and I need one for that positive 1. Now, when you do m to the 4th divided by an m squared, you know that you get an m squared. So when it comes to the number of rows and things that you're going to need, right, we know that we were going to have an m squared, we'd have an m, and then we'd have a constant. Okay, now after that, anything that you have would be for remainders out here. I'm actually going to leave those lines there, and I'll explain why here in just a moment. All right, so we'll put in our m to the 4th, right? And so that's all we're going to put in when we have this. We're putting that m to the 4th, right? We know this has to be an m squared, and then we're going to take this m squared and we are going to multiply it times each of those. So m squared times 0m would give me 0m to the 3rd. And then m squared times 1 is going to give me a positive m squared. Okay, so the key here with this one now is let's just look at this one. Okay, so I know that I need to have 3m to the thirds. So since I have 0, I'm going to go ahead and put in 3m to the thirds, which means that our missing value above here would have to be a 3m, right? It's positive. And then 3m times 0m is going to give me 0m squareds. And then 3m times 1 is going to give me 3m. Now the next one we have to look at, right, is going to be m squared plus 0m squared plus what is going to give us negative 9m squareds. Okay, well, 1 plus 0 is 1, plus what gives us negative 9? That's going to have to end up being a negative 10m squared, which means that the values that we're going to need out here would end up being a negative 10. Then we can do the same thing, distribute it through. We have negative 10 times 0m would be 0m. And then negative 10 times 1 would be negative 10. Okay, now we're kind of approaching the end here, but we've got a 3m and a 0, right? And it says that we have a total of 0m's up here, so we're going to need a negative 3m here so that when we add all three of these together, right, we get that 0m. Okay, but we also need to take into account the fact that we've got this plus 7 here, and we have this minus 10 here. So negative 10 plus what gives us 7? Well, that's going to be a 17, right? So we're going to have to add a 17. So this whole part out here is going to be our remainder. Okay, so we'll take it and we will say our answer will be m squared plus 3m minus 10. And then I'm going to go ahead and just say plus, and I'm going to put my negative 3m plus 17 in the top, and then my m squared plus 1 back on the bottom. And that is our answer. So if you have any questions about this one, please let me know. Otherwise, give the homework a shot, and any questions you have there, we'll gladly answer in class on the next day we have class. Thanks for watching.